Upon ISO individuals from Research Cluster 14 that revolves around university student life and rented accommodation, who lack offline socializing in the post-pandemic era. In an effort to reduce the negative effect brought by this phenomenon, this project introduces a new infrastructure system, a distributed network in the city in form of plug-ins inserted spaces in dwelling zones, to refine the micro-living environment. An application is introduced to the users to bridge the gap between renters and the rental accommodation, to achieve a visual searching and customization of the added facility clusters. An application named Pocket Build is developed as a part of our design to enhance the user experience, and it has two main functions: helping people look for rental housing and public space customization. On the city scale, users can look at the map from a perspective of data. They can browse real-time Rightmove data about housing, for example popular rental areas. In a closer district scale, the users can start filtering the ideal living area through sliders on the interface. By adjusting the parameters, buildings with suitable rental properties will be highlighted, and users can choose different categories of existing public facilities surrounding the house. Behind the interface is the selection regulations. The basic rule is the overlaying of data. We use the tools of resampling to clear up and visualize 4 clusters of data, including renters, house, transportation and socializing in pandemic era. We also introduce machine learning methods, principal component analysis, to correlate data in rental, age, convenience facilities, and people's travel mode. We select the sites with data that appear to have the highest contribution values. Here we have taken into account renter amount, public facilities density, open space and transport accessibility. Then, 8 small sites are filtered for users. Linking the existing public buildings in the city, a distributed network of functional space is built. It is a topological approach that visualizes the accessibility, convenience, and stability of functional facilities for users. We scrapped the rental photos from the Rightmove website and corresponded them to the map. Using image segmentation methodology, multiple city sections are studied to form a new urban perspective on the profile scale. We sliced the site and got 18 sections. Purple color represents building with rental points. White shapes represent indoor space of other buildings. On each section, the real room photos and street view are located. Then, apply a match segmentation to all photos. After that, we will achieve a new dataset, including visuality obstacle and green space percentage of street view, space edge, light and free space proportion of indoor space. Using the previous approach of slicing the city, it occurred to us that we could use cutaway entrances and foyers from the result of image segmentation, as well as the proportions of the building's interior space to simulate the crowd flow to shape the initial form. Using the shape from the last step as the basic point cloud, we did isovist analysis to obtain all possible locations for plug-ins in the venue. Use the evolutionary algorithm for topological optimization to calculate the best placement of the plug-in from the point cloud obtained in the previous step. The process of iterative operations was run for thousands of times in different sites and parameters. If we import different data, the result will also change correspondingly. It shows how that generation of cluster will meet specific requirements of users in specific era, which is the value of iteration. Then, we got the final calculation result, or the most appropriate positioning of clusters. For the more detailed design, it will take into account the latest requirements from students to achieve customization, by which the Pocket Build become a public platform that collect the collective intelligence from the students in a distributed network. We assumed 5 kinds of input with students' timelines surveyed from our college. Their requirements include study, live and recreation space. According to the user's daily activity timeline, many new functional facilities need to be built in the venue. Based on the requirements and the volume of different facilities, we have formulated a rule to transform the user needs into the proportion and number of the modules. For the connecting rules of modules, there are specific ones for different objects. Taking Cluster 1 as an example, firstly, silent areas, including self-study room and 24-hour study area, are separated from other functionalities. Secondly, in terms of distribution density, outdoor modules are arranged near apartments that lack green space, study areas are mainly next to apartments that lack light, and small rooms match more active units. We imagine what kind of space might be more in keeping with the theme. Perhaps the kind of functional hybrid space that is dependent on the building, or in other words, grows from the building into the public space. By the evolutionary algorithm for topological optimization, we try to shape the shortest paths and shapes for urban use and efficient traffic inside each central area twice, based on the results of the spatial boundaries of some buildings and roads in the city and the topology-optimized space. After the general shape is determined, we continue to deepen the specific space. The size and other parameters of spaces depend on their functions, but also have a module for easier assembling and iteration. Considering that people using the same type of space may also influence to produce different forms, we tried to explore more the different scenarios of a single functional space, a thought that is more like an idea from the inside out. Contrasting with our design thinking of urban scale from the outside in, the two seemingly contradictory approaches actually coincide with our theme of plug-in urban space. After the transformation, we finally have 5 kinds of clusters for students with different schedule. The service population is calculated by the rental data from Rightmove and student data from Census. They are allocated to the nearest plugin by algorithm. When the population change, the number and density of modules will follow it in the next iteration, by changing the proportion of circulation or empty blocks. In compliance with their original functional distribution, we have used different colors to distinguish their use, with the main connections being yellow, the study rooms being shown through green and so on. After the collection and facility update, the users will be given a result feedback to see the ideal rental house and the surrounding facilities. After checking in, they will also be able to book these facilities by the application. New images from street and rental rooms will be collected and segmented to join in the new dataset. The improvement brought by the plug-ins can be quantized and proved here. We can see the bird's eye view in day and night, and perspectives in different functional rooms. The modules inserted into the residential area are able to cater more requirements and improve the living condition of the rental house in multiple aspects. For example, in lights, and indoor and outdoor activities. We can see the dynamic paths a student might use in real-life situations. In his or her daily routine, the functions are used effectively to facilitate learning, living and recreation. And then when we step back to the urban scale, we can see the contribution of the plug-in space to the city. Reproducibility allows it to have considerable scale and influence, and to form new networks with other facilities